Okay, so, for this deep dive, you've given us a ton of material about the future of software applications. It's, well, quite a collection of software application research areas, excerpts. And I think our goal here should be to really pull out the most important insights, the ones that can, give everyone a solid grasp of what's coming next without getting too bogged down in the really technical stuff.
Yeah, exactly. Think of this as like your shortcut to understanding where software is going next. And from looking at all these sources, what we see are five really big themes. These are, the things that are going to shape software development in the coming years.
Okay, so let's lay those out. The first one, and it seems like it's everywhere, is AI integration, like AI just baked into everything. Then we've got the evolution of how we actually interact with software, UI, UX. Of course, you can't talk about software without security and privacy. That's a huge one, too. And then there are the architectural shifts, like how we actually build these things, distributed systems. And finally, there's the whole idea of sustainable software engineering.
And what we want to do is get past just listing those, right? We want to get to those nuggets, the key developments within each of these areas that are actually going to change the way you use apps and, software in general.
Absolutely. Let's jump into it. I guess AI integration is a good place to start. It seems like it really is the defining force, like it touches everything. And one of the areas that's generating a lot of buzz is generative AI. These large language models, or LLMs, are really showing some amazing capabilities. Think like creating text and images and even generating code all within an application.
And what's so important here is that it changes how we think about software at a fundamental level. I mean, traditionally, applications have been all about following predefined rules. You do this and that happens. But now we have applications that can produce truly new content, new outputs. A lot of the sources we looked at focused on the idea of prompt engineering. This is like the art of instructing these models, you know, giving them the right inputs so they generate what you want. It's almost like a new way of talking to software.
Yeah, that's a big shift. But it seems like it could also introduce some new challenges, right? Like, if you don't know how to prompt the AI correctly, will you be left behind? Almost like a new kind of digital divide.
That's a great point, something the researchers are definitely looking at. And it raises really interesting questions, too. Like, what new skills will people need in this world where so much content is generated by AI?
And this goes way beyond just making cool pictures or writing poems. Imagine an app that could create totally personalized learning materials based on your specific needs or automate those really complicated data analysis tasks that take, hours of manual work.
Exactly. The applications are immense. But there are also big responsibilities. A lot of the sources we looked at were focused on making sure that this content is high quality, relevant, and of course, not harmful in any way.
Right. Bias in AI generated content, that's a huge concern. Imagine getting medical advice from an AI that has built-in biases. It's kind of scary.
Yeah. Right. Yeah, totally. And then there's the technical challenge of actually running these huge models.
Yeah.
They require so much computing power, making them work efficiently within applications, making them scalable. That's a big engineering challenge.
Okay, so beyond creating stuff for us, AI is also transforming how we actually build software. A lot of these sources talked about AI-driven software engineering, using AI and machine learning to improve the whole development process.
So here's where things get really exciting. Think about AI actually generating code, and not just simple stuff. The goal is to have AI systems that can understand complex requirements and then write high-quality code based on them. It's still early days, but the potential impact on developer productivity is massive. I mean, it could totally change how software is made.
And it's not just about writing the code, right? There's testing as well. Some of these sources were looking at AI for automating software testing, automatically generating all these test cases and even using AI to do things like fuzzing and mutation testing. And it's not just random, right? The AI uses intelligence to find the most important edge cases to test.
Yeah, that's right. So instead of humans having to come up with all these scenarios, the AI can systematically go through and try to break the software in all kinds of ways. And, better testing leads to more secure and reliable applications.
Right. And there's even research on using AI to actually predict bugs before they even happen. Like the AI sees patterns in the code that might indicate a potential bug, and then it might even suggest a fix or, even implement it automatically.
Exactly. And it doesn't stop there.
Hmm.
Think about performance optimization. AI can help identify bottlenecks in the code or even in the underlying infrastructure. It's like having, this super intelligent assistant who's constantly looking for ways to make the software better.
Like a 24/7 quality control expert.
Yeah, pretty much. And some of the sources were even talking about AI's impact on UI design. analyzing how people use an application and using that data to design interfaces that are more intuitive and effective.
So not only is AI helping us design better interfaces, it's also like making them personalized, right? Adapting to each user's preferences.
Exactly. But it's important to remember that the goal isn't to replace human developers. It's more about augmenting their abilities, giving them tools to work smarter and focus on the more creative, high-level aspects of software development.
Now, as AI becomes more integrated into everything, there's this growing need to understand why these AI systems make the decisions they do. And this brings us to the whole concept of explainable AI or XAI.
What's interesting is that it's not enough for an AI to just work well anymore. We need to understand how it's making decisions, especially when those decisions have a real impact on people's lives. Like imagine an AI that's used to approve loan applications. If the AI denies you a loan, you should have the right to know why. XAI is all about making those decisions transparent so we can trust the AI and, if there's a problem, debug it.
So how does that work? Like, how do you make an AI's decision-making process clear?
The source has talked about a bunch of different techniques. There's feature importance analysis, where you try to figure out which factors the AI is using to make its decision. And then there are things like LIME and ESHEP, which are ways of kind of visualizing how the AI arrived at its output. And then there are rule-based explanations, which try to express the AI's logic in a way that humans can understand.
So it's about finding ways to make the AI's thinking understandable.
Right, and it's not easy. One of the challenges, according to the sources, is that more complex AI models, the ones that can be really powerful, are often the hardest to explain. It's like you can have a super smart AI, but you might not fully understand how it works.
So there's like a trade-off between accuracy and transparency.
Yeah, that's one of the big debates right now. And then there's the issue of who you're explaining it to. A developer needs a different explanation than, say, someone applying for a loan. So you need to tailor the explanation to the audience.
So to go from research to actually using AI in real-world applications, there's this whole field of MLOps and the need for a really solid AI infrastructure.
Yeah, MLOps is all about managing the entire life cycle of a machine learning model once it's deployed. So,
Right.
you've trained your model. Now you need to actually get it working in a live application. And that means things like deploying it, monitoring its performance, updating it, and so on.
So it's kind of like applying those traditional DevOps practices to AI and machine learning, right?
Yeah, exactly. Like you have to automate the process of building, training, validating, and deploying these models, just like you do with regular software. And then, of course, you need ways to keep track of all the different versions of a model so you can roll back if something goes wrong.
Yeah, that version control must be crucial, especially when models are constantly being updated.
And then there's the whole issue of model performance. Machine learning models can, start to lose accuracy over time. Like the data they were trained on might become outdated. So you need to be able to detect that and then retrain the model or make adjustments.
So MLOps is about keeping those models running smoothly, making sure they're accurate and up to date.
Exactly. It's a pretty new field, though.
Right.
There aren't really like standard tools or established best practices yet. So there's a lot of room for innovation.
It sounds like a really exciting area. And this brings us to, the other side of the coin. How do people actually interact with these applications? Our sources talked a lot about the evolution of UI UX, and it's clear we're going way beyond just keyboards and screens.
Yeah, one of the big trends is toward more natural interactions. This source is called the multimodal experiences. Think about really accurate voice control, where you can actually talk to an application in a natural way, not just using specific keywords. And then there are all sorts of possibilities with touch and gesture, going beyond those basic swipes and taps.
I've seen some cool stuff with gaze tracking too, where the application responds to like where you're looking on the screen. I guess that could be really helpful for accessibility, right?
Yeah, definitely. It opens up all these possibilities for people who might have difficulty using traditional input methods. And then there are even brain-computer interfaces, which are still in the early stages, but I mean, the possibilities are amazing, especially for people with disabilities.
But it sounds like the challenge is getting all these different modalities to work together seamlessly. Like the application has to know when to use voice, when to use touch, when to use ease tracking, and so on. It has to adapt to the user and the context.
Exactly. And to do that, it needs to understand how humans, naturally interact with the world, how we use our senses to gather information.
The sources also talked about immersive technologies like AR, VR, and MR. I feel like those have been on the horizon for a while now, but it seems like we're actually getting close to some real practical applications.
Yeah, the potential is there, but the sources highlighted a few big challenges, like designing interactions for those environments. In VR, how do you move around? How do you grab and manipulate objects? How do you get feedback that, you've done something?
And performance is a huge thing, right?
Yeah,
If the frame rate is too low or there's a lag when you move your head, it can be really disorienting, even nauseating.
exactly. Optimizing performance is crucial. And then there's user comfort. If the headset is too heavy or you get motion sickness, people aren't going to want to use it. The key is to go beyond just novelty and find applications that are truly useful. Things like, training simulations, collaborative work environments, educational experiences.
And this brings us back to personalization. The sources were really interested in these adaptive and personalized interfaces. The idea that the interface actually adapts to the user.
Yeah, so think about an interface that changes depending on what device you're using. Or maybe it adjusts the layout based on, like, your visual preferences. Or if it notices you're struggling with something, it might offer some extra help or guidance.
And this is where AI and machine learning come in, right? The system can analyze how you use the application and then learn to make those adjustments automatically.
Exactly. But one of the things the sources emphasized was that it's really important to give users control. Like, they need to be able to understand why the interface is changing and have the option to, override those changes if they want to.
And there's a growing emphasis on ethical and inclusive design too, right?
Yeah, absolutely. I mean, designing applications that are accessible to everyone, no matter their abilities, is crucial. This means following accessibility guidelines, integrating with assistive technologies, and just, making sure everyone can use the software. But it goes beyond that. It's about avoiding those, like, dark patterns, those sneaky design tricks that are designed to manipulate users. And it's about designing for user well-being, minimizing distractions, and promoting healthy habits.
Right. So ethical and inclusive design is about more than just checking boxes. It's about building trust with users and creating software that benefits everyone.
Right, exactly. And the sources pointed out that it's actually more cost-effective to build these principles into the design from the beginning rather than trying to add them later.
Okay, let's talk about security. It's an ever-present concern, and our sources explored a bunch of different ways that we're trying to secure this modern software ecosystem.
And one of the big areas of focus is protecting user data, which is, more important than ever. A lot of the research is looking at these really cool privacy-preserving technologies. Things like federated learning, where you can train machine learning models without actually sharing the raw data.
So the data stays on the individual devices, but the model can still learn from it.
Exactly. It's pretty amazing stuff. And then there's differential privacy, which is about adding noise to the data in a way that protects individual privacy, but still allows you to do, like, statistical analysis on the aggregate data.
So you can still learn from the data, but you can't identify individuals within it.
That's the idea. And then you've got zero-knowledge proofs, which let you prove something is true without revealing any extra information. And homomorphic encryption, which lets you actually perform computations on encrypted data without decrypting it first.
These are all really complex technologies, but they seem to be driven by, a really important goal, finding ways to use data without compromising people's privacy.
Yeah, definitely. And the sources noted that user awareness and government regulations are really pushing these technologies forward.
So it's a combination of technical innovation and social pressure.
Exactly. Another big trend is automation, especially in security analysis. A lot of the sources talked about DevSecOps and the importance of automating security testing.
DevSecOps is about baking security into the entire development process, right? Not just doing it at the end.
Exactly. And that means using automated tools to do things like static analysis, where you scan the code for vulnerabilities, and dynamic analysis, where you test the running application. And there's also this thing called interactive analysis, which is kind of a hybrid approach.
And AI and machine learning are being used in those tools too, right? To make them more effective.
Yeah, AI can help identify patterns in code that might indicate a vulnerability, so it can be really helpful.
So it's all about finding those vulnerabilities early, before they can be exploited, right? And that means integrating these tools into the CI/CD pipeline so security testing is happening continuously.
Exactly. The goal is to make security everyone's responsibility, not just the security team. It's a cultural shift.
Modern software development relies on so many different components and libraries, third-party stuff. And that creates this whole new set of challenges. Our sources talked about the importance of software supply chain security.
Yeah, this is a big deal. You might be using code from all these different sources, and you need to make sure it's all secure. So there's a lot of research on things like vulnerability detection, where you're scanning all those dependencies for known vulnerabilities. And then there's this idea of provenance tracking, where you can actually trace the origin of each component and make sure it hasn't been tampered with.
So you're making sure that all the ingredients in your software are safe.
Yeah, that's a good way to put it. And then there are things like secure build processes, where you're trying to prevent vulnerabilities from being introduced during the development process itself.
So it's a multi-pronged approach to addressing this really complex problem.
Yeah, exactly. But even with the best security measures, it's all for nothing if people don't use them properly. And this is where the idea of usable security comes in.
Right, making security features that are easy to understand and use.
Exactly. The sources stress the importance of designing security interfaces that are intuitive so people don't get confused or frustrated. And then there's security education, making sure people understand the risks and how to protect themselves.
And it's not just about education, right? It's also about making security less of a hassle.
Right. Like things like passwordless authentication can make things so much easier for users while also being more secure. The key is to understand how people actually behave and design security measures that work with those behaviors instead of against them.
So it's about human-centered design, but for security.
Exactly. Okay, so let's shift gears and talk about how these applications are actually built. Our sources went pretty deep into distributed systems and cloud-native applications.
And one of the things that keeps coming up is serverless computing and edge computing, right? These seem like they're changing how we think about infrastructure.
Yeah, serverless is all about abstracting away the infrastructure so developers don't have to worry about managing servers and all that stuff. They can just focus on writing their code.
So you're essentially offloading the infrastructure management to the cloud provider.
Exactly. There's a lot of research on serverless design patterns and understanding the trade-offs. Like, it can be super scalable and cost-effective, but there are challenges too.
What kind of challenges?
Well, things like performance can be a little unpredictable, and managing state can be tricky. And then there's the whole cold start problem where you have to wait for a server to spin up if it hasn't been used recently.
And edge computing is about pushing computation closer to the user, right?
Exactly. So instead of everything happening in a central cloud data center, you can process data and run applications on servers that are closer to the user or even on the user's device itself.
So things like latency would be a lot lower?
Exactly. And it opens up all sorts of possibilities for applications that need to be really responsive, like, real-time gaming or augmented reality.
And the sources talked about hybrid architectures too, right? Like combining serverless and edge with traditional cloud infrastructure.
Yeah, it's not an either situation. You can mix and match these different approaches to create the optimal architecture for your application.
Microservices are another architectural pattern that seems to be evolving pretty rapidly.
Yeah, microservices are all about breaking down an application into these small, independent services. And that can have some big advantages in terms of scalability and maintainability, but it's not easy.
Yeah, managing all those different services and making sure they all work together smoothly, that sounds like a real challenge.
It is. There's a lot of research on things like improving the resilience of microservices so they can handle failures gracefully and making sure you have good observability so you can understand what's happening across all these different services.
And security is a big concern too, right? I mean, you've got all these different services communicating with each other, so you have to make sure that communication is secure.
Yeah, definitely. And then when you move to cloud-native applications, security and compliance become even more complex.
Because now you're dealing with like the shared responsibility model, right?
Yeah.
Where the cloud provider is responsible for some aspects of security and you, the application developer, are responsible for others.
Exactly. And you have all these new technologies to deal with, like containers and infrastructure as code, so security best practices have to evolve. The sources talked about securing containerized applications, making sure your infrastructure as code is secure, and using tools like cloud security posture management to get a handle on your overall security posture.
It's like a whole new set of challenges, but it's also an opportunity to rethink security from the ground up.
Yeah, exactly. Okay, last but not least, let's talk about sustainable software engineering.
Yeah, this one seems to be getting a lot more attention lately.
Rightfully so. The environmental impact of software is becoming a big concern. The sources we looked at talked about green computing for applications, which is basically about reducing energy consumption and carbon emissions.
So how do you do that? Like, how do you make software more environmentally friendly?
Well, there are a lot of different approaches, like You can optimize algorithms to be more energy efficient. You can reduce the amount of data that needs to be transferred, and you can optimize the infrastructure the software runs on.
So it's about being more efficient with resources at every level.
Exactly. And there's research on things like energy-aware development practices, where you're teaching developers how to write code that's more energy efficient.
And being able to measure the environmental impact of your software, that's got to be important, right?
Yeah, if you can't measure it, you can't improve it. There's work being done on developing standards and methodologies for measuring the carbon footprint of software, which is super important.
Well, this has been a pretty amazing journey, exploring all these different facets of the future of software applications. It's clear that these 5 areas, AI integration, the evolution of UI, UX, security and privacy, distributed systems, and sustainability, they're all connected and shaping the future of software in really profound ways.
Yeah, you can't really talk about one without talking about the others. They're
Yeah.
all influencing each other.
And it seems like AI is this pervasive force,
Mm.
right? It's impacting everything from how we build software to how we interact with it.
Yeah, AI is the big game changer. And at the same time, we're seeing a real focus on making software more human-centered, designing experiences that are intuitive, accessible, and ethically sound.
Security and privacy, those are always going to be critical concerns, especially as software becomes more complex and interconnected. And distributed systems, well, that's how we're going to build the next generation of applications, the ones that can scale to meet the needs of billions of users.
And all of that has to be done in a way that's sustainable. We have to consider the environmental impact of the software we create.
This has been an incredibly insightful deep dive. I mean, we've just scratched the surface, but it gives you a sense of the amazing innovations that are happening and the challenges we need to address.
Yeah, it's a really exciting time to be in the world of software.
So for you, the listener, think about the applications you use every day. How might these trends change them? What kind of new possibilities do you see? What kind of future do you want to create? Thanks for joining us.